starting. Okay, this video is me going over the first midterm, and I'm going to show you guys how to do every single problem on here. Starting with number 1, order of operations. Notice that I did the 2 minus 3 inside the parentheses before I'm taking the cube. And negative 4 squared, where the negative is not being squared, is negative 16. Also, negative 1 cubed is negative 1. So this becomes 5 times negative 1, negative 16 minus 5, negative 21. Next problem, scientific notation. We're multiplying, which means we're going to multiply the two constants, and then we're going to multiply the 10 to the power of 10 times 10 to the power of 6. So the two constants is 3.5 times 5, and for this multiplication, we're just going to add the exponents. So that's times 10 to the 16th. Now 3.5 times 5 is 17.5 times 10 to the 16th. And this isn't in exact scientific notation. We only want one number to the left of the decimal point. So we're going to move it over, and that gives us 1.75 times 10 to the 17th. Next, we're going to solve this equation for x. So first I'm going to apply the distributive property on both sides. So the left side becomes 5x minus 5. The right side becomes 7 minus 8x. And then we have a negative 2 times negative 33, so that's going to be positive 66. Now I'm going to simplify the right side. 7 plus 66 is 73. So now we have 73 minus 8x on the right, 5x minus 5 on the left. Now I'm going to add 5 to both sides. So I have 5x equals 78 minus 8x. Now I'm going to add 8x to both sides to get all the x's on one side. And that gives us 13x equals 78. So the last thing to do here is to divide both sides by 13. And we get x equals 78 divided by 13, which turns out to be 6. Okay, the next question asks us to find an equation in slope-intercept form for the line containing these 2 points. So the first thing we want to do is find the slope. And since we only need 2 points to find the slope, we can do that immediately. So we're going to do, I'm going to call this one x2, y2, and this one x1, y1. So if I do y2 minus y1 over x2 minus x1, that gives me 9 minus 6 over 8 minus 4, which gives me 3 over 2. So that's my slope. Okay, that gives me 3 over 4. So that's my slope. Now that we have our slope, we can use 1 point to find our y-intercept. So I'm going to write the general equation, y equals mx plus b. We already know m, it's 3/4, so we have y equals 3/4. Y equals 3/4 x plus b. Then we're going to use the point 4, 6, and we're going to plug the x value 4 into x and the y value 6 into y. So we get 6 equals 3/4 times 4 plus b, which gives us, the 4's cancel, it gives us 6 equals 3 plus b. So b equals 3. And now we can write our full equation. Y equals 3/4 x plus 3. Okay, true and false is next. First, a function can have two different inputs with the same output. This is true. For example, in y equals x squared, we have the inputs 2 and -2 both going to 4. So that's two different inputs going to the same output. So that's true. Next, the graph of a linear function has a slope that is some constant number. Yes, this is true also. That's why we can write it in slope-intercept form. So here the constant number is 3/4. For number 3, we can find the y-intercept of a graph by setting x equal to 0. That is also true. Given a graph, if we want to find where the graph crosses the y-axis, well, the graph crosses the y-axis right when x is 0. So here x is positive, here it's negative, but right here on the y-axis it's 0. So that's true. A constant function takes the form f of x equals c for some real number c. Yes, that is true. That is the definition of a constant function. So here the graph of a constant function y equals 5, or f of x equals 5, is a horizontal line at 5. Lastly, the domain of a function is the set of all possible outputs. That is false. The domain of a function is the set of all possible inputs. The range is the set of all possible outputs. Okay, number 5. Deduce from the table whether the function is linear or nonlinear. Okay, so the way that we're going to do this is we're going to notice that the top row of our table gives us the x values, and they increase by 1 each time. From 1 to 2, 2 to 3, 3 to 4, 4 to 5, and so on. So if the function is linear, then the y value should be increasing by some constant amount each time. So let's see, from here, -7 to -3, we're adding 4. -3 to 1, we're adding 4, so far so good. 1 to 5, we're adding 4. 5 to 10, we're adding 5 here. So it changes, it's not a constant value, so this function is nonlinear. Okay, notice from this table that the x values increase by 1 each time, from 1 to 2, 2 to 3, 3 to 4, and so on. So if the function is linear, then the y value should increase by some constant amount each time. It doesn't have to be 1, but it has to be the same thing each time. So for the first 3, we're adding 4, from -7 to -3, -3 to 1, and 1 to 5. But then we start adding 5, so it is not constant. Therefore, this function is nonlinear. Okay, page 2. So consider the following function. F of x equals the square root of 1/2 x minus 3. For part A, we find f of 6. this means that we take 6 and we plug it in for x. So we get the square root of 1/2 of 6 minus 3. And then we can simplify that. 1/2 times 6 is 3. So we get 3 minus 3. And that is the square root of 0, which is just 0. So f of 6 equals 0. Now I'm going to take a plus 2 and plug it in for x. And we can't simplify much, but we can distribute this 1/2. 1/2 a plus 2 times 1/2 is 1 minus 3. Now 1 minus 3 simplifies to minus 2. So our final answer is 1/2 a minus 2 and the square root of all that. Okay, the domain and range of f. To find the domain, we just need to remember that what's under the square root cannot be a negative number. So we're going to take what's in the square root and we're going to set it greater than or equal to 0. And then solve for x. So add 3. And then multiply both sides by 2 to get rid of the 1/2. And that gives us x is greater than or equal to 6. So if I'm going to write it in interval notation, I'm going to say the domain equals 6 to infinity. Now what about the range? Well, we just need to remember that for a square root function, since we're never taking the square root of a negative number, we're only taking square roots of 0 or positive numbers, and those will always give us 0 or positive numbers. So the range is always going to be greater than or equal to 0, because we will never take a square root of a positive number and get something negative. So the output can never be negative. So our range is 0, infinity. Okay, next, consider the relationship where the set of inputs is the people in this class, and the rule is to match them to their PSU ID number. Would this relation be a function? Why or why not? Well, let's see. In order for something to be a function, we just need to know that there are no inputs that go to more than one output. So, does any student have more than one ID number? No, we all only have one ID number. So, every input only goes to one output. So yes, it is a function. So every student has only one ID number. Thus, every input goes to only one output. So yes, it is a function. Okay, great. Next, solving an inequality. I'm just going to solve it using our regular rules for solving equations. And just remember, if I ever multiply or divide by a negative, I need to switch my inequality. So distributive property here on the left gives us 15 minus 5x is less than or equal to 4x minus 3. Now I'm going to combine the two constants and by adding 3 to both sides. So that gives us 18 minus 5x is less than or equal to 4x. Now I'm going to add 5x to both sides to get all the x's on one side. And that gives us 18 is less than or equal to 9x. And now all I have to do is divide by 9. So that gives us 2 is less than or equal to x. And in interval notation, that just means we start at 2 with a closed bracket and off to infinity. Okay. Next, another inequality. This one is a compound inequality, and I'm going to solve it all together. But whatever I do to the center, I'm going to do to all three sides. So first I'm going to get rid of all the denominators by multiplying by the least common multiple of the denominators, which is 12. So I'm going to multiply all three parts by 12. So that's going to give me 12 over 4 is less than or equal to 12 times 3 minus 5x over 3 is less than or equal to 24 over 3. And now I can simplify. 12 over 4 is 3. 12 over 3 is 4, so this gives me 4 times 3 minus 5x. And 24 over 3 is 8. So now I'm going to get rid of this pesky 4 by dividing all three sides by it. And that's going to give me 3/4 is less than or equal to 3 minus 5x is less than or equal to 8 over 4, which is 2. Now I still have 3 minus 5x in the middle. I'm still trying to isolate x in the middle, so I'm going to subtract 3 from both sides. So 3/4 minus 3. Well, let's see. Over here we have, I can rewrite 3 as 12/4. So there I can see that 3/4 minus 12/4 is negative 9/4. And then 2 minus 3 is negative 1. And now I can divide everything by negative 5. So back over here, negative 9/4 divided by 5 is just going to give me negative 9/20. That's divided by negative 5, sorry. So that's going to give me, so negative 9/4 divided by negative 5 is going to give me positive 9/20. And remember, since I divided by a negative number, I need to switch the inequality. So I have positive 9/20 is now greater than or equal to x. And here I'm also dividing by a negative, so that's going to make it greater than or equal to negative 1 over negative 5, which is 1/5. So now I'm ready to write my answer in interval notation. X is greater than or equal to 1/5, so I start with 1/5 over here. And it's less than or equal to 9/20. So that's my answer. Okay, next page. All right, T represents the number of minutes from the time that the car enters the highway. Write an expression involving T for the number of minutes since the truck has entered. Well, the truck entered 12 minutes before the car. So if T is the time for the car, then T plus 12 is the time for the truck. B, what are the speeds of the car and the truck in miles per minute? Well, the car is going 60 miles per hour, and I'm going to divide by 60 to get miles per minute. So the car is going 1 mile per minute. The truck is going 75 miles per hour. I'm going to divide that by 60, and I get 1.25 miles per minute for the truck. Now, I want to find how many minutes it will take the car to pass the truck. So when the car passes the truck, their distance is going to be equal. So I'm going to use the equation distance equals rate times time for each of the car and the truck, and then set their distances equal. So then I'm going to have rate times time for the car equals rate times time for the truck. So the car is going 1 mile per minute. It's I messed up the speeds. They need to be switched. Oh, this sucks.